I start inshallah, and I hope all of you fine. We start lecture 2 about chapter 7, and as we know, I must do a quick review about the last last lecture. So the quick review: last lecture we discussed about the work. So the work, we used a sample of the word W. From the word W we use a first letter W. So the work is equal to the force F multiply the distance multiply cosine theta. Cosine theta. And we know from the last lecture F, the force, measure with a unit of Newton, the distance meter, so Newton multiply meter is equal to joule. So the unit of the work is joule. Then we discussed about the two important things of energy. So the energy can be divided into types: kinetic energy and potential energy. And we know the kinetic energy, that is the energy when the objects move, and it's equal to half mv square, and in this lecture we prove it, this equation. It's not necessary for you, but I prove it for you to know from where this equation came. Potential energy, and we know as a definition, it is the energy when the object in its position or in heights, so it equal to mgh. mg, that means the width multiply the height, so it is equal to be E. Now today we start with this question. So the question is, what? Look at the figure and find out the work done by the object or the man. He moves as shown in figure. So first I look to the figure and described in my mind what I can do. So from lectures that we study together in class, so we know there is some shapes under the graph. هناك أشكال تحت المنحنى. إذا هنا كم شكل؟ So I have two triangle. عندي مثلثين, two triangle, مثلثين, اثنين مثلثات, مثلث. مساحة المثلث, the area of the triangle is equal to n half base multiply the height. نص القاعدة في الارتفاع. So now I think it's very easy. So find it with the first one. That is the first one till here, number one. That is number two till here, and give me the result. So number one, A1 is equal to half base multiply height. Half constant, base 6, height 1, so it's equal to 3 U. Number 2, A2, it's equal to half base here from 6 to 16, so that means 10, multiply the heights 2, so 1 5, so it's equal to 10 joule. So the work done, it's equal to area 1 plus area 2, so it equal to 3 plus 10, it's equal to 13 joule. So that is the answer of the first question, or the first example. Second example, a piece of wood with 6 kilogram mass moves from the rest when 6 Newton force applied on it. Find the velocity when it covered a distance of 3 meters. So first of all, I mentioned to you to read the question carefully and take the information from the question. So in this question I have a mass m is equal to 6 kilogram. Number 2, from the rest when 6 Newton force, so F is equal to 6 Newton applied on it. Find the velocity, so I need V when it's covered, so there is another value that it's given here, that means H, it's equal to 3 meters. So what equation can I use to find or to solve this problem? Think, try to use the correct way to solve this problem, and also try to use the good equation that solve for you this problem with all the information that given in the question. Okay, so we start. I start to solve it with a new page. Insert page. So the information that I have, m is equal to 6 kilogram. Then F is equal to 12 Newton. D is equal to 3 meter. Anything else that I have? The question is find V. So here he wants V, so that means V, it is in kinetic energy, so that means half mv squared, so that is 1. Number 2, F and D means the work. So W, it's equal to F D. It's not mentioned about the cosine or the angle, so don't worry, just only if he mentioned about it and given, okay, not given, so don't worry about it. So 12 multiply 3, it's equal to 36 joule. From the previous lecture I know that the change of KE, it's equal to work. So the work is equal also to change of KE, no problem. You can do it, or do it from here, no problem, do it from here. So KE half mv V square equal to the work 36 joule. Then half m, it mentioned, multiply 6 V square, it's equal to 36 joule. So substitution the equation, so V square, it's equal, here is 3, 36 divided by 3, so it equal to 12. So V is equal to the square root of 12, 3.46 meter per second. Same, this question is very important to note and to try to read and try to solve more in that way. So that is the second example. Now our lecture, it discussed about the work and the kinetic energy. So if I have a box or an object, I want to move it from point to point. As we mentioned before, we need to apply a force. This force keep this object to move. So from Newton's second law, I know F is equal to ma. So the work done is equal to Fd. Substitution the work equation with Newton's second law. So W, it's equal to MAD. So what I do, just only F, I substitute it with F in second Newton law, substitution it with F for the work. So F of Newton's law, MA, F of work, FD. So then the work, it's equal to MAD. As we know, the acceleration here, it's due to the gravity. The gravity, it's constant, 9.8 meter per second square. So I can multiply the equation from the kinematic equation. I have the third equation, V final squared, it's equal to V initial squared plus A twice of acceleration D distance. That is the third equation of kinematic equation. Use this equation and multiply it with half m. So half m V final squared equal to half m V initial squared plus 2AD. A here is gravitation, D 2AD. If I multiply this 2AD with half m, so half equal with 2, so it gives me this part. So MAD from the previous equation, it is the work. If I move this outside, so half mv final square minus half mv initial square, that is the change, the rate change of the kinematic energy, it's equal to the work. This is the equation that we use to solve example 2. So the change of the kinetic energy it's equal to the work done by it. إذا من حسب قانون الشغل، فالشغل يعتبر أو يعبر عنه بالتغير في طاقة الحركة. بالنسبة لهذه الاستنتاجات كلها أنت ما مطالب فيها. This all proving it's not necessary for you. Just I want to show you how you can find this equation and how you prove that is KE is equal to half mv square, to know it from where it came to this equation. So the relation between the work and the kinetic energy means the change of KE it's equal to work. التغير في طاقة الحركة هو يعبر عنه بالشغل، فالشغل هو أيضا عبارة عن تغيير في طاقة الحركة. Now the relation between the work and potential energy. In some references the potential energy they give the sample of U, so don't worry, U, PE, it will be mentioned about this thing. So if I have an object, إذا عندي جسم object حجر مثلا or box stone, I want to move it to up, so the stone cannot be moved. الحجر لا يستطيع أن يتحرك, so I must be applied force to move it from H2 to H1, so it change its highest position to from 2 to 1, so I need to apply force. So that means minus here means the object cannot do work to move alone, so you must apply a work on it to move. When it's move, so that means it change its energy from potential to kinetic energy, so that is the mean of minus sign here. The mean of minus sign, that means the object in potential energy it cannot be moved. If you want to move it, you must be applied force to it to move. Last point, and I upload for you practice problem today, inshallah. I hope that I try to apply for you some practice problem, and I try to solve some equation or some problems in quick way, because some students they send to me by email some solution. So it is very important to know قانون حفظ الطاقة، قانون حفظ الطاقة. وأعتقد أن كلكم عارفين الطاقة لا تفنى ولا تستحدث ولكنها تتحول من شكل إلى آخر. So the energy cannot be destroyed. The energy cannot be destroyed. It may be transformed or changed from one form to another, but the total amount of energy never change. It's still same. I go through the practice problem that I given for you last lecture. So first question, I think number 1 true. The answer is true. Number 2, as a body fail, the potential energy increase with the speed, so that is false. Number 3, it is number C, true. Number 4, it is C. Number 5, what is the kinetic energy of kinetic energy Ke need of 900 kilogram car moving with 30 kilometers. So that means I must be convert 30 kilometers per hour, 30 kilometers per hour, sorry, 30 kilometers 30 kilometers per hour. So I must be converted to uh, meter per second. So I using the conversion uh, unit, how to convert. So 30 kilometer per hour, 1 hour, it's equal to multiply 1000 meter, it's equal to 1 kilometer. 1 hour to 300 3600 seconds. Just I flip because I need to remove, so kilo moves with kilo, hour with hour, so the result is 8.333 meter per second. Then I think it's very easy now. Ke, it's equal to half mv square, so it's equal to half m 900 and v square 8.333 square. So by using the calculator, it is 31,250 joule, or it's equal to 3.1 multiply 3.1 multiply 10 to power minus joule. That is number 5. Number 5. 7, there is no 6, sorry, I don't know about that. So number 7, number C, network do not do on the object. The gravitational potential, number 8, the multiple choice, it is number A. 9, question 9 is C. So how much the work is done if you raise? So potential energy, it's equal to mgh, so it's equal to 6 mg. It's already done, it's given, because raise white here, give you the white, so it's already done. Multiply by 15, so it's equal to 1.5, so it's equal to 9 joule, so it is number C. Number, I think I move to number 12. Number 12, or I give you the result, because I solve all the questions, so I give you the result. Number 10, the final result, it's F1, 11, 2 over 3, 12, 390.6 joule, 13, 19.8 meter per second, 14, H, it's equal to 45.9 meter. Number B, let's say number B, or the first part. Second part, 20, 25 meter per second, it is the V, and you can check it. Number 15, 15A, A is equal to 100 joule, P it's equal to 20 Newton. So that is the important questions. Thanks a lot, and I try to upload for you more practice problem. See you, and take care about yourself, and I hope all of you find